Any other question? So, I want to start chapter 4. Let me see how far we are going. We were supposed to complete chapter 4 this week, but we are going to be a little late about it, but we will make it up next week. I put a lot more material around this part. So we started with these sums last time. I hope you were able to complete it. It wasn't difficult from what I started. So we can do the sum of the x squared, the sum of the regular value, and we have done this one also already. So I'm going to skip this. And for the infinite sum, we have done it also. This one, you just want to remember what it is. You get it from calculus, the Maclaurin series, the power series of a function. Have you heard about that? Anyone here? This kind of expression of E of x? You are used to E of x equals to, what definition do you have of E of x? You are used to E of x is equal to 1 plus x over n raised to power n. Limit as n tend to infinity. But what we are saying now is that E of x is also the limit of this series, xn over n factorial, n equals to 0, infinity. So this is another expression of E of x, which we will be using from time to time, either the first or the second. Have you seen the first? You used the first before. You are used to the first one. You are used to the first one with this expression, the limit of 1 plus 1 over n raised to power n tend to e as n tend to infinity. So when we get to it, we will discuss it again. So now we want to define a uniform distribution. So a distribution is called uniform if its random variable x is in the form 1, 2, 3, up to n, and p of x is equal to 1 over n. Example is when you roll a die. 1, 2, 3, 4, 5, 6. When you roll a die, the probability of getting any of these numbers is 1 over 6. So this is a uniform distribution. There could be some modifications of this uniform distribution to obtain some other type of distribution. For example, if y if I say y equals to 0, 1, 2, 3, 4, 5, then P of x equal to 1 over 6 is also a uniform distribution. So it is that the probability of each of the value is the same. That's the idea of uniform distribution. We can see here that y is equal to x minus 1. So we will use the classical uniform distribution to be able to explain what happened to any other form of distribution. If we square this x, we will have 1, 4, 9, and so on. And the probability of getting any number from that random variable will remain the same as 1 over n. So it will still be a uniform distribution. So we want to learn from this that if x equals to 1, 2, 3 is uniform, then the mean of x is n plus 1 over 2, and the variance of x is 1 minus is n squared minus 1, I'm sorry. N squared minus 1 over 12. So what we will try to do is to prove this. If x is uniform, then P of x is equal to 1 over n for all x. P of x will be the sum from 1 to n of x times P of x. Which is equal to the sum from 1 to n of x times 1 over n. Because the distribution is uniform, the probability is the same, which is 1 over n, sum from 1 to n of x. And this is what we did last time. This sum is n times n plus 1 over 2. And this gives us n plus 1 over 2. To find the variance, we will first do e of x squared is equal to sum of x squared plus p of x from 1 to n, which is sum from 1 to n of x squared over n. P of x equals to 1 over n still, which is 1 over n, 1 to n, x squared. So remember what we say was the sum from 1 to x to n of x squared, 1 over n times n plus 1, n plus 1 over 6. I'm referring to this formula here, the sum of the first square. So we can see that e of x squared is n plus 1 times 2n plus 1 over 6 because of this 1 over n here. So the variance of x is e of x squared minus e of x squared. And e of x squared is n plus 1 to n plus 1 divided by 6. Minus, remember e of x, n plus 1, n plus 1 squared over 4, which is n plus 1 square, n plus 1 over 2 square. So the common denominator here will be 12. Now we will multiply the numerator here by 2. Minus 3. Which is equal to, we can factor n plus 1. Now multiply here by 2, we will have 4n plus 2. Minus 3n minus 3 over 12. It is n plus 1 times n minus 1. It is n squared minus 1 over 12. So in most of the type of problem with uniform distribution, you will have to observe how the distribution you have is a transformation of the uniform distribution that we have here. And use the formula for transformations of variables to answer the questions. For example, let y be equals to 0, 1, 2, 3, 4. Uniformly distributed. E of y, variance of y, and standard deviation of y. So we will observe that x is equals to 1, 2, 3, 4, 5. Then y equals to x minus 1. And x is uniformly distributed with x is uniformly distributed with mean of x equals to n plus 1 over 2. The 5 plus 1 over 2, which is 3. And variance, the variance of x is n squared minus 1, 5 squared minus 1 over 12, which is 24 minus 1, I'm sorry. Which is 24 minus, I'm writing the answer. 5 squared is 25 minus 1 over 12, which is 24 over 12 equals to 2. So we will now have that E of y is equals to E of x minus 1, which is 3 minus 1 equals to 2. And variance of y is equal to variance of x equals to 2. And the standard deviation of y is square root of 2. So what I'm saying is that if you have a uniform distribution, you can transform it, or you can relate it to the classical uniform distribution, and you don't need to do all the computations again. This is called a discrete uniform distribution. Okay? Next section, 4.2, the Bernoulli trials and the binomial distribution. So for the next 5 minutes, we will just discuss the Bernoulli trial. The Bernoulli trial is a trial with exactly 2 outcomes: success and failure. In a Bernoulli trial, there is exactly 2 outcomes: success and failure. If the probability of success is P, the probability of failure is Q equals to 1 minus P. When you are taking an exam, you are doing a Bernoulli trial. You can pass or you fail. But the probability of passing, you cannot tell. When you win lottery, you buy a lottery card, you are doing a Bernoulli trial. You can win or you can lose. So we want to define the random variable associated with a Bernoulli trial. In this case, the random variable is 0 or 1. 0 for no success, 0 for failure, 1 for success. In a Bernoulli trial, the number of success is either 0 or 1. So it defines a probability distribution like the one we have here. This is the probability distribution of a Bernoulli trial. 0, probability Q, 1, probability P, and we know that P plus Q must be 1, so Q equals to 1 minus P. When you toss a coin, it's a Bernoulli trial. You can say 0 is head and 1 is tail. So I want us to complete today with finding the mean, the variance, and standard deviation of a Bernoulli trial. Let's equal to be a Bernoulli random variable. Probability distribution will be 0, 1, x, p of x, q, p, p plus q is equals to 1. Then we can see that E of x is 0 times q plus 1 times p, which is p. So the mean of a Bernoulli distribution is the probability of success p. E of x squared will be what? 0 squared E of x squared will be 0 squared times q plus 1 squared times p, which is again p. So the variance of x is E of x squared minus E of x squared, which is p minus p squared, which is equal to p times 1 minus p, which is equal to pq. And the standard deviation of x is square root of pq. If you consider tossing a coin as a Bernoulli distribution, the probability of success is half, so the expected number of heads will be half. When you toss a coin, the expected number of heads is half. And the variance is 1 over 4, half times half. Standard deviation, half. This is a very simple distribution, but useful in defining and doing proofs as we move on. Okay, 1 minute to disinfect before we go. So are you ready with the graded problems? I think I should give you a lot of more problems like playing around before you get to that's the advantage of this class. Anthony, what is your major? I mean, do you have a concentration? Yeah. I was thinking that if you like, you can take T05. It's just like a continuation of this class. And give you the option 1, maybe if you like to do options. Yeah. But T05 will be doing a lot of problems, but this will
be doing it all together. Those problems are the similar problem I give you, but I don't want to give you too many. But in 305, we do a lot of problems. We solve more of those type of problems because we are hoping that at the end of the class, you will be able to take the exam. And that course, the 305, has been approved already by the Society of Actuaries. Our 205 and 305 have been approved. So I will talk to Jared too, if he's interested. Okay? So that you join Maggie so that she shouldn't be alone in her class next semester. I know Jacob is too busy. You are not done. There is a lot of math you can still do, but the requirement, you are done with the requirement. Okay, Daisha, we are done.
Okay, thank you.
You're welcome.
Enjoy your weekend.
Thank you, you too.
Thank you.